I've already preloaded it because I've literally just typed in h of x minus x as a function here. There's h of x from the previous question, and then minus x. And so what we're doing here, we're doing h of x subtract x. Now if you think about it, this is actually two functions and the difference between them. What we're actually doing here is we're finding the area bound by the top function here. Let me just put my pointer on here. So this is integral of h of x, and integral of x is here. And if we subtract them, we're actually finding the area between the two functions. And presume that this 2.02 is this intersection, and this is the top intersection here. Okay. Now I actually just graphed this on my TI Nspire, and can you see on my graph I've got this guy here. And now if I go menu, analyze graph, zeros, then this bottom zero, can you see, is the 2.02, and menu, analyze graph, 0. Okay, and what you'll find is that area, if we do menu, analyze graph, if we do integral between here and here, that area that we've just found on the TI Nspire corresponds exactly with the area identified between the two curves here. Okay, so we've just transposed the pink area, the area between the two functions, into this single area between the combined functions and the x-axis. And then we can just read it straight off on the calculator. And so that particular answer is part 1. We have 2.02, and that would be to 3 sig fig. And then part 2 is quite nice, isn't it? Because can you see that the area of the region enclosed by the graph of h and the inverse function? Well, you just need to know about the shape of function and inverse function, because isn't the inverse function just a reflection in y equals x? So the inverse function is going to be something like this. So by symmetry then, whatever answer we've got for the area here is just going to be doubled to give this. So we need just times 2. So for part 2, go for the full answer, 2.02134 times 2, and that's 4.04, and that's also to 3 sig figs. Then finally part C, and again I'll go back to the diagram. We'll just try and get in here and have a little think about it. It says let D be the vertical distance from a point Q on the graph of H. So here's a point Q, and this is the distance D. Okay, so can you see D is the height of h of x minus the height of y equals x. And so all we want to do is find the maximum of D. Okay, let's just write out what D is. D equals to 2 plus 3 ln x minus 1 times cos of 0.1x and then minus x. But actually we've already got that on our TI Nspire graphed here. Look, that's f1 of x. So all we have to do is we just use this to find the maximum D, and you can see quite clearly where it is. Menu, analyze graph, maximum, and there we've got our final answer to this question. And there's the maximum here. Now there's one little trick to the last part, of course, that the x coordinate is 3.44 to 3 sig fig. But notice the q value here is the value of h of x minus x. So we actually have to add on x back on here. One way of doing it is just go back to h of x and substitute 3.43963 into h of x. Now remember, h of x doesn't include the minus x. So what we have here is that the y value of q is h of 3.44, and you should find out that that is equal to, let's have a little look, 0.962 plus 3.44. Let's do that on calculator. Doc, insert calculator, and we've got 0.962 plus 3.44, and there we've got it. We've got the y coordinate is equal to 4.402. So there you go, q is at 3.44, comma 4.402. Sneaky last little bit there.